Hello, I'm Blauth, and today I will tell you about the Fast Optimizer benchmark, or short FOB, as we usually call it. Now, to give you a quick overview, what FOB is. It is a development tool for deep learning optimizers. It is configurable, yields fast results, and is designed to be extensible. It is also convenient to use, being easy to set up, and featuring Slurm integration and an included plotting pipeline. It is also an ensemble of tasks that can be reused for other applications as well. Now, what FOB is not is a competitive benchmark that tries to establish a new leaderboard. There are some benchmarks already out there, so one question is, why didn't we just use one of those? For example, the recently released ALGPerf, which is a competitive time-to-result optimizer benchmark. Well, first, they have exact hardware requirements, meaning that if you do not have said hardware, you sometimes don't even get a score at all. Also, it consists mostly of larger tasks, meaning that you have to wait longer before you get your results, which is not optimal when iterating on an optimizer design. Our conclusion was that this is good for a final benchmark once you're done developing, but not suitable for development itself. Now back to FOB. There are three main components of FOB. The tasks, which consist of the dataset, model, and a performance metric. The optimizers, which consist of the optimizer and the learning rate scheduler. And then we have the engine, which takes care of the configuration, execution, and running of the training pipeline. This modular design makes it easy to plug in your new optimizer and also even extend it with your own tasks. Now, speaking of tasks, these are the tasks that are currently available. We have some smaller tasks that only take a couple of minutes on a single GPU, but also some larger tasks that require multiple GPUs and have a larger runtime. Now, how to use FOB? Well, the general workflow is that you specify your experiments with YAML configs. This allows you to reproduce and share results easily, as you just have to share a single file, allowing for reproduction. We try to keep these configs minimal by having default values everywhere. So in fact, this is the most minimal config that you can build, just specifying which tasks to run. Obviously, you can override these default values wherever you want. And you can also specify multiple runs in a single experiment file by using lists. So whenever you put a list in your configuration file, FOB will run a grid search over these lists. So in this case, you have 3 lists with 2 elements each, resulting in 8 runs in total in this config file. Now I will quickly go through some usage examples. First, if you want to simply use it as a benchmark, you can just specify all the tasks you wish to run. Then, if you want to compare two optimizers on a given task, you can specify them side by side, each with their own set of hyperparameters. Then, if you want to plot said experiment, you can also do that with the integrated plotting, giving you this nice graphic here to give you a quick overview of your experiment. Now, we've seen that you can easily have a lot of runs in your experiment file. And to make it easier to run those on a cluster, we have also included Slurm support in FOB. So by specifying some more lines in your experiment, you can have FOB just schedule all of these on with Slurm. You can also use FOB with existing hyperparameter optimization frameworks by importing it into your file and then specifying your target function, which converts a SMAC config into a FOB config. So, and then FOB will take care of the run training, the checkpointing, and the resuming of runs. Now, FOB is available on GitHub, and there are more examples and instructions in the repository. So feel free to try it out yourself, and thank you for watching.